Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Hello, future engineers, subscribers, students, and viewers. Here is another video in calculus, and I hope that you will learn from this video. To the curve, part A, y equals x absolute value of x, and B, y equals square root of x to the fourth minus 2x squared plus 1. For x less than or equal to 0, absolute value of x is negative x. When x is negative, so the absolute value of x, because it is always positive, is negative of x. So if x is negative, negative of negative value is positive. So that's why absolute value of x is equal to negative x when x is less than or equal to 0. So therefore, y equals x times negative x, y equals negative x squared for the case where x is less than or equal to 0, or from negative infinity to 0. For x greater than or equal to 0, absolute value of x is equal to just x. So y equals x times x. So it is x squared when x is positive and 0. So we didn't plot the curve from negative infinity to 0. So we just substitute x equals negative. So and including 0. So when x is 0, negative of 0 squared is 0 here. When x is negative 1, positive. When x is negative 1, so it is negative of quantity negative 1 squared, so negative 1. When x is negative 2, negative 4. So as the graph looks like as shown, then for positive value of x, y equals x squared, it is an open upward parabola. When x is 0, y is 0 also here. When x is 1, y is 1 here. And when x is 2, y is 4 here. It passes through that. So it looks like that, then we just extend the shown. So that's it for that part A. For part B, y equals square root of x to the fourth minus 2x squared plus 1. That is also equal to quantity square root of quantity x squared minus 1 square, or simply x squared, y equals x squared minus 1. Then when x is 0, y is negative 1. When x is negative 1, the domain, by the way, is from negative infinity to positive infinity, because the expression inside is always positive because of the power, even power, and always also positive. So when x is 0, y is negative 1. When x is plus minus 1, y is 0. And when x is plus minus 2, y is 3, and so on and so forth. So we just consider this case, the vertex, this is a parabola, this is open upward, the vertex is at 0, comma, negative 1, but if you're not familiar with the standard equation of parabola, it's fine. We just plot this by point plotting. So when x is 0, y is 0. When x is plus minus 1, when x is 0, y is negative 1 rather. It is an open upward parabola. When x is plus minus 1, y is 0. So the parabola passes through these 2 points. This vertex 0, comma, negative 1. When x is 2, 2 square minus 1 is 3. So it passes through this point. When x is 2 and negative 2, also that point, and we just extend. So it looks like that open upward parabola. So that's it for these two functions and their graphs. Let's proceed to the next problem. It is shown in physics that the attraction of a thin spherical shell of radius a upon a particle at distance b, where b is not equal to a, from the center is a equals quantity k over b squared. So that's the condition that B should not equal to A, or else we have division by 0 again. But A minus B can be 0. So A over B square quantity 1 minus A minus B all over square root of A square minus 2AB plus B square. Show that A is K over B square quantity 1 minus signum of A minus B, and that A is 0 or A is 2K over B square according as the particle is inside or outside the shell. So this is square root of A minus B quantity square. So A is K over B square quantity 1 minus A minus B all over square root of A minus B quantity square. And square root of A minus B quantity square may be also be represented by absolute value of A minus B. So A is K over B square quantity 1 minus A minus B over absolute value of A minus B. So when A minus B is less than 0 or negative, then this ratio is negative 1 because A minus B is less than 0 or A is less than B, and that means the particle is inside. So it is negative 1. If A minus B equals over absolute value A minus B equals 0, then that means A minus B is 0. So it is equal to 0. And A minus B over absolute value of A minus B equals 1, positive 1, if A minus B is greater than 0 or A is greater than B, and that means the particle is outside the shell. So therefore, this is the definition of signum function. So A is K over B square, quantity 1 minus signum of A minus B. So because this satisfies the condition of a signum function. So when the particle is inside, A is less than B, or when the particle is outside or inside rather, because A is greater than B, the radius of the particle is A, and A is greater than B, so that means the particle is inside because the radius is greater than B. So A minus B is greater than 0, so that means in this signum function here, this is replaced by 1 because when A minus B is greater than 0 or positive, signum of a positive value is 1. So 1 minus 1 is 0, therefore A is 0. And when A minus B is less than 0, signum of A minus B would be negative 1, and the particle is outside. And if the particle is outside and A minus B is negative, signum of a negative value is negative 1 from here. So this is 1 minus negative 1, which is 2. So A is 2K over B square. So that's it. And it's really true that when the particle is inside, A is 0. And when the particle is outside the shell, A is 2K over B square.